All right, so we are in section 6.3 HL. I'm on explain 1 where it says justify the hypotenuse leg congruence theorem. So first off, some review vocabulary. A right triangle, the side opposite the right angle, remember that's called hypotenuse. So hypotenuse has that big long name. It also represents the biggest, longest side of the triangle, the side that's opposite the right angle. The two sides that form the sides of the right angle are called the legs. Short name represents the two shorter sides. Also, we've now learned 4 ways to prove triangles are congruent. ASA, SAS, SSS, and AAS. HL is the last one. Below there's a box that says hypotenuse leg triangle congruence theorem. And it states if the hypotenuse and a leg, so that means the longest side of each triangle and one of the shorter sides of each triangle, if those are congruent to the hypotenuse and a leg of another triangle, then the triangles are congruent. So you have to have 2 pairs of corresponding sides. One of those sides has to be the hypotenuse, and they both also have to have a right angle for this to work. We're not going to go through example 1. Basically, this is just a proof on how HL works, but it's useful to look at this diagram for example 1 because this is a representation of exactly what HL looks like. You have triangle ABC and triangle DEF. They're both right triangles because angle C and angle F are both 90 degrees. The longest side is congruent. Side AB is congruent to side DE. So that's the H in HL. And then they also tell us side segment BC is congruent to segment EF. That's the L, that's the leg of HL. So those triangles are congruent because of HL. But again, for HL to work, they both have to be 90-degree right triangles, which they are. So there is a your turn at the bottom of the page. It says determine whether there is enough information to prove that triangles VWX and triangle YXW are congruent. Explain. So I'm going to give you a second to look at this diagram. This one's tricky because the triangles are overlapping, but see if you can determine if you're given enough information to tell that they are congruent. And if so, why? And I'll go ahead and give you a hint. The triangles are congruent. You've got to figure out why. So take 5 seconds, pause the video, and we'll go over it on the other side. All right, so we have 2 triangles. We have triangle VWX and triangle YXW. They are both right triangles. We can tell that much because angle V and angle Y are both 90-degree angles. So this is obviously setting up for HL. So we're looking at the big triangles. It's tricky because it kind of looks like we may be focusing on the smaller triangles in this problem. But again, notice what the original problem is talking about. It's talking about the big triangles. Triangle VWX and triangle YXW. They both have a congruent side. So segment VW has a hash mark through it. It's congruent to segment YX. So that is our congruent leg. Notice this isn't an official proof. I'm just giving a brief explanation. So we have our congruent leg. All that's missing is the hypotenuse. Well, if you look really closely, the longest side of both of these triangles is the same side. That's side WX. They both have that segment in common. So if they both have the same hypotenuse, well then of course their hypotenae, that's how you say hypotenuse plural, hypotenae are also congruent. So they're both 90 right triangles. They both have 90-degree angles. We have a congruent leg. We have a congruent hypotenuse. So these triangles are congruent by HL. Let's go to the next page and encourage you to pause the video. They've done example 2A for you. So read through that problem and make sure you're understanding each step of the way. It's a 2-column proof. Everything's been done for you. Read through that. And remember, there's a lot of different ways to write proofs. If you want to write it as a paragraph proof, that is fine. But they start with the first two statements, both as the given statements. Statement 1 solidifies both of these triangles as right triangles. Statement 2, segment PS, is congruent to segment RQ. Those are the legs of each triangle. So we have a congruent leg. And then we can see the hypotenuse, just like the one we just did. The hypotenuse, they both have the same hypotenuse, segment SQ. So segment SQ is congruent to itself. That's called the reflexive property. And at that point, that's enough information to prove the two triangles are congruent by HL. I again encourage you for example B. This time they've given you all the statements. Pause the video and see if you can write the reasons in the right-hand column. So statement 1, angle J and angle L are right angles. That is the given. K is the midpoint of JL and MN. That is also the given. Statement 3 says segment JK is congruent to segment KL. It also says segment MK is congruent to segment NK. And the reason being that, well, think about it. If K is the midpoint of the longer segment, by definition of a midpoint, it's right in the middle. So it's kind of cutting these long segments into two smaller congruent pieces. So those pieces are congruent by definition of a midpoint. And if you think about step 3 real carefully, JK and LK, are those legs or are those the hypotenae of the triangles? JK and LK are the shorter sides. They're the legs because they help form the right angle of both those triangles. And then segment NK and segment MK are the hypotenae. Those are the longest sides, the sides directly opposite of the right angle. So again, these triangles are congruent by HL.